Okay, 1.5 is all about dividing integers, and we are check interested. So let's keep going. Dividing integer rules are the exact same as multiplication rules. If you are dividing two integers that have the same sign, the answer is always positive. If you are dividing two integers that have different signs, the answer is always negative. The chart remains the same as well. If the first and second number are both the same sign, you'll always get a positive answer. And if the first and second number are always different, you will always get a negative answer. The good news is the division you already know doesn't change. You just need to check the signs once the quotient is found. And the quotient is what we call the answer to a division problem. So let's go over the examples here. Be sure to copy them in your notes, and we'll start with example 1 and 2. Give it just a second here to load. We're going to start with example 1, and this is going to be your basic dividing integers with the same sign. So example 1 is going to be negative 18 divided by negative 6. This is the one way we will see division, but in junior high we tend to see it more as a fraction. The division never changes. We still think about our fact families, and 18 divided by 6 is 3, and then a negative divided by a negative is positive. So our answer there is positive 3. For example 2, now we're going to look at when we have different signs. 75 divided by negative 25. And remember, we are only grouping the negative sign with the number to separate this so people don't think it's 75 divided by minus 25. It's a negative 25. So the division doesn't change, and you can use your calculator for that if you want, but 75 divided by 25 is 3, and then a positive divided by a negative is a negative. So our answer is negative 3. And here we have negative 54 divided by 6. Again, it's a fraction, but fractions also mean division. So the actual math of 54 divided by 6 is 8, and a negative divided by a positive is a negative. We're going to start with. Okay, actually, on that problem, the answer was not 8. It was actually 9, negative 9, but we all make mistakes. So moving on here, we're going to watch example 3, and this one has variables that we'll be taking and substituting in values, and it's important that you do not substitute. Example 3 for dividing integers. In this problem here, we see that there are variables and they're asking us to evaluate this expression when x equals 8 and y equals negative 4. So I immediately see some exponents, I see subtraction, I see division, so I know order of operations is going to come into play. So I'm just going to write off to the side the thing that I dislike the most, but I know you guys all like, which is PEMDAS, but notice I wrote it a little different. So first things first is before you start solving anything is to input the values, substitute them in. So I have 10 minus x squared, and x is 8. So 8 squared, or raised to the second power, divided by y, which we now know is negative 4. Okay, so in order of operations, I take care of parentheses. First, this is not parentheses, that's just grouping the negative with the 4. So I go to exponents, and I have 8 squared. And we learned in our last section that there are no parentheses around this, so it's just the just the 8 being squared, not the negative. So the 10 minus stays, 8 squared is 64. Bring down your divided by negative 4. So I took care of exponents. Now I do multiplication and division from left to right. So here's some division. So the 10 minus gets brought down, and 64 divided by negative 4. If I wasn't sure with my calculator, I'd do 64 divided by 4, but I know that it is 16. And then a positive divided by a negative is a negative 16. Now I have subtraction, and I'm down to my last step. And I learned a couple sections before that anytime we have subtraction, we keep change. So my 10 stays the same. My minus sign becomes a plus, and I change the sign of that next number. My negative becomes a positive. And now we just simply have a an addition problem of 10 plus 16, which is 26. What I was going to say before the video started is that you want to make sure that you input everything for the variables first before you start changing any signs or anything. So back to our notes, and we're going to click on example 4 and watch this video. In our last example, it's telling us that we measure the height of the tide using the support beams of a pier. At 2 p.m. in the afternoon, it's at 59 inches high, meaning the water is that high up to that level. At 8 p.m., it's 8 inches on the pole, so it's gone down, right? It decreased. You measure, your measurements are shown in the picture. What is the mean hourly change in the height? So you want to write down this phone number. You want to write down this formula. To find the mean hourly change, you're going to take the final, in this case, height. Maybe it's grade, maybe it's something else, but in this case, it's the final height minus the initial height, which is the beginning amount, right? So it's the final amount minus the beginning amount, all over the amount of time, the elapsed time. So how much time went by from 2 p.m. to 8 p.m.? Well, you can count and figure out that that is 6 hours. So we know that's going to be our denominator. Our final height is where it's the latest time of the day, so that would be 8 inches, minus the initial height, which was 59. So we substitute in, and we end up with 8 minus 59 divided by 6. Now, again, order of operations. This fraction bar acts as a grouping symbol, so we got to take care of everything up below, up on top. So this becomes 8 plus a negative 59, because we always keep change. And when we do that subtraction then, because the signs are different, we do 59 minus 8, and we get 51, and 59 wins the tug of war, so it's negative 51 over 6. And now we have a division problem that we could go ahead and divide. And negative 51 divided by a positive 6, a negative divided by a positive is a negative, and then the math is 8.5. So that means that over that 6-hour period, the mean change in the height of the tide was negative 8.5 inches per hour, which means it decreased 8.5 inches every hour on average. Okay, so that was our last example. And on our next screen here, we're going to try these problems on our own. So press pause, take a few minutes to solve these problems as best as you can. And we'll go through them now. On the next slide, I went ahead and found our answers here. Negative divided by a negative is a positive, and a positive divided by a negative is a negative. And here we want to go ahead and plug in our numbers as they appear here. Every time we see an A, we input in negative 18. And anytime we see the B, we put in negative 6. So we end up with an answer of 3 for number 3. And we end up with an answer of negative 1 for number 4. And in number 5, after quite a few steps, we end up with an answer of 2. And that'll be the end of it. Let me know if you have any questions.